But in essence, what we have been able to accomplish were quite a number of successful products, many of them involving polymers, and that's kind of like the focus of today's talk. So the best one, or the one that's best known, is the Precedent golf car, which basically took club car from about 30% market share to 80%. So we also used a lot of polymers on the 787, and that was a very, very successful project for Munro. We got on very, very early, so we could have a big influence. When there was 5 people on the program, 2 of them were Munro, myself and Dan McCarthy. So what I want to try and do is let's get into why we're here today and why we're in this kind of a situation. So in 1900, this was Fifth Avenue, the Easter Parade, and I want you to see if you can find the car. Let me show you. Okay, so there's the car. Let's push ahead a bit, and let's go to 1913. Find the horse. Did you get it? Nah. Click. Let's do that. There you are. There's the only horse on the street. Now, why was this so important? Why was that such an important slide? The reason is because in 11 years, car ownership went from 7.7% to 80%. This is the kind of situation we're in right now. So what was the key driver to make everybody go away from horses to cars? Pollution, horse pollution. And quite frankly, they were looking at basically a foot of horse manure on the streets at the end of the day. It was impossible to keep up. Impossible. So they had to move from one polluter to another. So we have the ICE vehicle. So we're in the midst of something called a paradigm shift. And when a paradigm shifts, everyone goes back to zero. Your past success means nothing. When you have a paradigm change, no one will go back to the old paradigm. Steam engines, stone tools, kerosene lamps, whale-borne corsets, all of those are gone forever. And those who are really successful in a dead or dying paradigm, those guys, they'll have their vision blocked to the future. And that's kind of what we're seeing right now with many of the companies that are out there, especially the guys that are making cars. So in about 2014 or 15, we tore apart our first vehicle. Then the first electric vehicle we took apart was the BMW i3. And when I saw it, I saw lots of technology, I saw lots of potential, and I tried to let everybody know, hey, we're going to tear this apart and let's all pay Munro Associates a lot of money so that so that you can catch up on whatever the technologies are. We lost our tail. I almost killed the company because no one cared. In 2017 and 2018, we started tearing apart Teslas, the Tesla Model 3. And I said, you know what? The body build is terrible and the paint is horrific. And I have no idea how they're going to stay in business. But you know what? These guys have got something that we really need to pay attention to. And that was on John McElroy's show. I received hate mail and all kinds of things. And then when I found out how much money they were making on these cars and reported that, then I got hate mail from the opposite group. So first I got Tesla fanboys that tried to tell me they were going to come and blow my factory up in the middle of the night. And then it switched to short sellers who were very unhappy that I found that, the good things that had to do with the Tesla vehicles. In 2019, I went around the world basically professing what I'd come up with. And at that time, I made a couple of predictions that I'll talk about in a little bit. But at that time, I was basically, I went to Japan first. They booed me. Then I went to Korea. They sat there patiently listening, but rubbing their chins. Singapore, the people in Singapore, that was mostly finance. They wound up applauding. China, but I was preempted by Chairman Xi, who basically said, he wanted to drop the number of electric car companies from 680 down to about 150. So when I got to I also went to Qatar, and but when I got to Norway, that was absolutely brilliant. When we got to Norway, everybody was standing up, cheering and applauding and whatnot. And the reason for that was because they had already moved in that direction. Now, when we got to 2020, I started making a series of videos and whatnot, telling people, hey, you know what? You should sit up and pay attention to this. This is coming on really fast. About the same time, VW made a prediction that people were going to give up on electric vehicles and go to biodiesel. That didn't work out real well. In 2021, I revised my prediction on when EVs would take over more than 50% of the market share, and I made that on Autoline Detroit as well. That was definitely met with a lot of resistance. So what were my predictions? The predictions that I made basically was that actually initially it was 2030, but I've changed it. I updated it to 2028. I thought that maybe 75% of the Japanese market, Japanese and South Korean market, would be EVs, and then we move over to China. 70% of China would be EVs. Europe, 80%, and in North America, probably around 55%. I was met with a lot of disparaging remarks, and if I had to do it over again, because I'm not going to change the slides now, things are happening too quickly, but if I had to do it over again, I'd swap, because China right now is already at 37%. 37% of the cars being made right now are either EV or hybrid EVs. Norway, Sweden, and Denmark all are kind of leading the way, as it were, in this new adoption of EVs. So China, I think, is going to be the dominant EV manufacturer for a decade. Chairman Xi announced that China will endeavor to reduce its carbon emissions to reach carbon neutrality by 2060. That's actually a little out of date. He now wants 2045. I think that about 75% of China will be EVs by 2030, and I think the number that Chairman Xi would like would be 100% EVs by 2035. Now, to stop the manufacturing of ICE vehicles, that's gasoline, he's looking at that for 2040, and that might also be a little lagging behind. So how is China dragging the future, even with companies that don't want to move? If you look around, you can see that if we look at North American operations, North American OEMs, it's not hard to figure out that Ford is in the lead. I mean, they've got several different EV vehicles out there that are basically bought into infinitum. They can't keep up with the demands. The Lightning being the one that I bought a Lightning for our company because it's so much better than what we had before. I mean, we were spending on our diesel a 2500 Ram. We were spending something like, if we ran it for real for a month, we'd be spending around $400 a month. Now we're spending about $9. I mean, this is like ridiculously ridiculous to even think that I want to go back to an ICE vehicle. If we look at all of the different things that are happening in China, you can see that they basically command or demand the attention of anybody that wants to be in the EV world. If we look at the next chart, this is where I think the top 10 will be in 2030. And I may have to revise this a smidge as well. I think it might be that Ford might go up some, and GM and Toyota may go down some, and Hyundai and Kia and Honda may go back up, along with Nissan. This is like impossible really to gauge, but I will tell you for sure that the production rates out of China and out of Tesla are vastly different than anybody else's. And I will predict that China holding at least 26% of the market share here in North America, I'm pretty sure that that's going to happen. I don't believe that Biden will be able to hold them back because China holds all the keys. Remember, I just showed you a chart a second ago that shows all the stuff for electric vehicles that we didn't want to make here in the United States is being made right now in China. And so we were stuck buying it. And that's just the way it's going to be. Let's go to the next one. This is called the Valley of Death. I have a chart that's almost identical to this, and but I called it Death Valley. So I'm using Connect the Dots chart because, quite frankly, if I use all my own data, everybody thinks I'm just making it up. So this Valley of Death is where we are looking at the demand for EVs is there. However, there's no way to manufacture them here locally. And this is where I believe that the Chinese are going to get their big chance to basically jump to the forefront of the market share. I want you to pay attention to the very light green colored bars. That's the Valley of Death, where the demand is there, but the supply is not. And this is where I believe the Chinese will have their opportunity to come in, while the rest of the geniuses that were out there that said, oh no, EVs are just a passing fancy, or let's try and market the EVs into a corner and let them starve to death. The biggest problem with everybody, this is the Altman Z-score. Now, I'm sure that many of you are investors and things like that, and you kind of believe what is coming out. But this score, this Altman Z-score, this talks about who's got the most money, who can afford to do whatever, and in essence, this is what I base everything on. Now, there's a line right there. It's called the danger zone line. And you can see that only 3 car companies are edging into the gray zone. And that would be Toyota, Honda, and Tesla. You'll also see that there's a lot of other companies that you actually absolutely know, and they are in a danger area. Now, some of you may have wondered why Volkswagen would ever sell off Porsche. The reason is because they also use this chart. They also know that they've got to invest, and they invested heavily on the diesel coming back, or people disregarding the ability for ICE, or people to move from where they are to an ICE vehicle, or from an ICE vehicle to an EV. They made a mistake. So now all these guys are going to have to scramble around and try and figure out how can they survive, or how can they exist, or how can they reinvest. This is a really severe kind of situation that you've got here, because people have to ask the question, why should I invest if I know there's a huge risk? That's why Tesla stock keeps going up, and a lot of the other stocks either go flat or are going down. So what's accelerating this movement? Well, there's 2 things. One is the Russian invasion. But I will tell you what is going to happen, and that is that the price of fuel is going to go up. So I'm telling everybody to get prepared for a $10 a gallon in less than 5 years. And the reason for that is simple. History. Historically, and I am old, so I was there when gasoline went from 2 bits a gallon to $1.50. And I'm telling you that these are the prices that were the average in the United States from 74 to 82. And I watched that gasoline go crazy. I watched people in big long lines when gasoline went nuts in those years. And this was the opportunity for Japan to come in with their products. The Japanese product basically gave you good fuel economy, had high quality, and they were smaller, but hey, you know what? They were a lot less money to buy, and a lot more economical from a traveling standpoint. So I'm recommending that everybody go back to their history books and read about Jimmy Carter years. Okay, this is something that's coming on really fast. I think China is the most prepared, and I know that history repeats itself. Sometimes it's different countries or companies that get the get the kick upstairs or whatever. But China is definitely in a good position to take on the planet. I think that if I've got advice for people, I think you got to start looking at lightweight, not steel. And I think that that's why one of the main reasons I did this webinar is because I truly believe that the future is going to be in composites for sure. So to you, pick your customers with care, run away from ICE programs, save your capacity for EV, go as fast as you can, acquire talented small companies that have developed new technologies, and remember, your enemy is not money, it's time. You've got to move as fast as you can. So here's what I'm proposing or talking about here a little bit. And the reason I'm doing that is because it's good to know the whole project or the whole of what's going on, so that you can discount things that are going to come in your direction. People forget that that TV commercials that's what actually pays for TV, and believe me, they bend in the direction of where they're going to make more money. So when you hear about the 4680 and stuff like that, and EVs in general being not so reliable, or how are you going to get them serviced and whatnot, it's good to understand that the future design is multifunction. And why is that? Well, when you start fooling around with looking deeply at electric vehicles, you find out there's no service. And I'm talking about the battery pack right now. Ever, never, ever. It's reliable. It carries the seats into the car. How many people do you know would load the seats in on the battery tray? Tesla does it. It comes straight up from the bottom. It's absolutely brilliant. It gets rid of at least six or eight stations on an assembly line. Not only that, I can put the thing together so much more easily than the way it's done now. Structurally, this is a great big gigantic brick that if you get smashed into is going to slow down anything that's coming your direction. And because the 4680 batteries are cylindrical, they don't pop like a prismatic. So it's structural and it's recyclable. The way you recycle this thing is you take the whole battery pack out and you drop it into liquid nitrogen. It's chewed up into small particulate, and then it's floated at different, everything floats at different densities, and then skimmed off. I've been told by the people at Tesla who are already recycling that their biggest problem is they haven't got enough batteries to recycle. They really want to recycle batteries because it's much cheaper, much easier to recycle the ingredients that they need from recycled batteries. So again, a lot of stuff, a lot of things that you've heard aren't quite true. So this one here is another little chart. A bigger battery means more range, or in some frequent terms, when we look at things where we got to have a lot of range, if we look at the Tesla Model S Plaid, it's got 390 miles. It has an average of 101 miles per gallon by the EPA standard. And we look at the Bentley, that's got about similar kind of horsepower. It's sitting there at 380 miles per tank. Its average gas mileage is 19. Gas mileage in the city is 16, 102 for the Tesla. If you look at all of the things that are on this chart, and I'm not going to go through all of them, you start to see that somebody has been pulling our leg. And so what we need to do is we need to be very careful about what happens when people send us information. Let's go to the next slide. This is one that I really have problems with. If you look at the top bar, it's 75 kilowatt hours of power in the battery pack for the Tesla Model Y. If we look at the 21 Mach-E, they have 88 kilowatt, so quite a bit bigger. 82 kilowatt hours out of the Volkswagen ID.4, but look at the size of the Audi e-tron. Look at that, 95 kilowatt hours. So you'd think, well, you could drive around the world with the Audi, right? Wrong. So anyway, let's look down here. 125 miles per gallon is again, through the EPA calculations. We look at the Mustang, 101. We look at the Volkswagen, 97. Now, the guy with the biggest battery, 95 kilowatt hours, look at that, 78. I mean, like I said, the next thing that Volkswagen is going to have to rid itself from is going to be Audi. So if you're an Audi fan, get ready to buy stock. So everything that we talk about when we're talking about how we're going to get range, and most likely, these things are all the same. They're all calculated the same way. Number 1 is weight. Number 2 is energy efficiency. Number 3 is friction. Number 4 is drag. How do we make everything work? Composites, 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 composites. This is how composites are going to start taking over the world, because I can reduce weight, I can get engineered efficiencies, I can get rid of friction because I can do things on a composite vehicle that I'd never be able to stamp out of steel. And then friction can go away in some degrees by using composites. Sometimes in bushings and things like that, and obviously drag. Now, there's going to be some other changes that are going to be coming out. On your left there, you can see one of the mega presses that are giga presses that come out of Hydra. The 2020 Model Y Megacasting is sitting there on the right. Now, we have 2 of these things sitting on our floor, both the front and the back castings, because we've just taken apart a Model Y. And if you're interested in anything that goes on inside of that, we do sell very detailed and very accurate cost assessments on why it might be a good idea to move to this. The reason that I'm showing this is because there are going to be 2 ways to basically save money and produce cars at a higher rate. And the one is going to be using the gigacastings. The gigacasting general manager announced, the guy in charge of Hydra, that he'd just been able to secure the first order for an 8,000-ton die casting machine. That die casting machine is for the Gigafactory, and that'll be making the front or rear or some part of the Cybertruck. Now, it's reduced piece cost, reduced investment cost, and the floor space needed is only about 1/3 of the normal size that I would need for a body shop. This is like huge, but it's not the only way that we can see new things happening. So if we look at this one, I've already talked about high pressure die casting, but guess what? You have 2 choices for volume production, at least currently. One is the high pressure die casting. The other is injected molding or sheet molded compound. Now, the 2 parts that you see there are the 2 major parts that went into the club car vehicle that I showed you just a bit ago. Let's talk about some of the other things that could help out. If you look at the VW ID.4, if you open up the hood and look down inside there, you'll see a ton of hoses. Those hoses are not happy. They're not happy because they can get kinked and bent, and it causes some extreme problems with the pumps. They wind up cavitating and whatnot. Now, our friends over at TI Automotive, they came up with a new way of making things happen. They have presented this to the folks at ID4 or Volkswagen, but I think Volkswagen wants a cheaper price. But I don't really care whether TI or anybody gets this job. What I'm looking at is, how are engineers going to think in the future? How are they going to make the decisions they need to make in order to create the future with the highest possible uptime, no serviceability and whatnot, and it's all going to be composites and plastics. Now, like I said, I've been following this for a while. We tore apart the BMW i3 life module. We tore apart the whole vehicle, but what you're looking at is the life module. Now you got two guys holding up that lady and the life module. And today I gave 2 tours still looking at that life module. Now that's made out of carbon fiber, and I wouldn't really exactly recommend that style of manufacture for that product, because that was then and this is now. But you can also see that if you just look at the equivalent in a body in white for steel, the BMW weighs 148 kilos. A steel body in white would be 349 kilos. Now, right now, people are paying about $5 a pound. $5 a pound to get rid of weight. That is a great way to do it. So this is the Nobe. The Nobe is a 4-piece carbon fiber body. This will be sold in the United States, but right now their target market is Europe, and actually it's just been certified to go to Japan. So what does it look like without the paint on it? This is it right here. You can see that this is a really beautiful exterior. Tragically, it has to get they painted it, but this is a lovely exterior. Here's what's really neat about it, though. This is a perfect build. Now, for people who don't really understand what it's like to try and put a stamped body together in a car plant, a perfect build never happens. There are no 2 bodies ever that come out the same. And the reason for that is because every time you stamp a piece of steel, there are little imperfections inside that steel that make it want to warp or bend. And so stamping doesn't give you the same, it gives you something close, but it doesn't give you the same part. If you look at welding them together, it warps even more. With this, when you make something out of composites, it's going to be perfect every time. So that's the Nobe. Let's look at another one. This is the Aptera. Aptera is, you'll be able to buy one of these next year, mid-year. This is a 1,000-mile solar car. In other words, if you're below the Mason-Dixon line, you may never put a penny into charging your car or buying gasoline or anything else. And the reason for that is because this car is the most effective and efficient. Remember I said it's weight, and this thing is really light. It's engineering efficiency, and they have done a great job with not only the efficiency of the design, but also the electronics and the characteristics associated with power distribution. Then you've got the dynamic of aero. This thing is obviously tremendously aerodynamic. This is about as good as it can possibly get, but could I make that out of aluminum or steel? And the answer is absolutely not. So what is it going to be made out of? It's made out of 4 pieces, big pieces, of carbon fiber. And like I say, I can't show you too much, but I can show you one of the prototypes. And this lady is holding up the whole roof of the prototype Aptera. And then if we move down here, Munro redesigned a ID4 battery tray. Now they use prismatic batteries, and we're going to redo this whole thing to show what it looks like with 4680s in it. But for right now, this one here there are a ton of different polymers out there that have a fire retardant. But the best part about this is I can get thermal and electrical insulation. When I look at composites, I'm looking at something that's going to give me things that I can't get out of anything else. So I've got free insulation. And I don't want the battery pack to be affected by how hot it is or how cold it is outside. I want an insulation barrier. This works phenomenally well. The coolant paths, I can mold them right in. Cable connections, I can mold them right in. High voltage wireways, I can mold them right in. Battery locators, I can mold it right in. It's got less weight and less cost. So let's find out how much less weight and how much less cost. The top cover went from a total of $105 down to $54.70. And by the way, these have already been vetted. I'm just going to go to the bottom so we've got time for questions and whatnot. So if we look at the bottom line, the total cost of the VWRD4 battery pack without the batteries in it was $1,662. With our new design, $879. And this again is using composites that are widely available in the marketplace. So with that, I'd like to shut it down and take on questions. Thank you for your time, and carpe diem, seize the day. Thank you.